Geometric transformations. This is a fun digital lesson. It teaches the transformations of reflection, dilation, translation, and rotation around the origin. And this one is Thanksgiving themed. The lesson starts with a definition of transformation and then what it means in mathematics. Slide 3 has the definition of the 4 transformations students are going to use in this lesson. They can refer back to slide 3 anytime they need a review of what each of these mean. They're going to start with reflection on slide 4. So they're going to use the fill color feature of Google Slides, and they're going to show each of these reflections. So a reflection is a mirror image of a figure across a line. So it's going to be equal distance from the line, but a mirror image. So students are going to click and hold in any of the squares they want to color in to show this mirror image. So they click and hold, and then they can scroll across the squares they want to color in. They're going to come up here to fit the fill color feature, and they can choose any color they like. Now they're going to highlight a couple of their squares, so click and hold. And they can only highlight a rectangle shape at a time. So there'd be 3 steps to this one. And there they have a reflection across the y-axis. The next slide is also a reflection across the y-axis, but this time a different shape. So this one again, they're going to click and hold. And they can choose a different color if they like. So it's a mirror image across the y-axis. Now the next one is the same shape, but this time they're going to be showing reflection across the x-axis. So this one's going to go straight up. It's kind of fun to fill in the squares for the students. Then they move on to a reflection across a line that's not the y or x-axis. So here they're going to reflect this figure across the line x equals 1. So it has to be equal distance from that line and a mirror image. So again, they just highlight and create their mirror image. Then they're going to be reflecting across the line y equals -1. So in this case, the reflection will be down at the bottom. Then they're shown what to do if they're reflecting across a line and the figure is already partly across that line. So I've put a couple dots here that show that this is going to work like a hinge. So if they take this figure and they flip it straight up on that hinge, this is what it would look like. And students are going to try that with a different figure on the next slide. Then we move on to translation. So translation is just moving a figure up, down, left, or right without changing its orientation. So the first one's pretty simple. It's a square. So this one they're going to translate 6 units to the right. So it'll look like this. Now the other translations, they're going to be making 2 movements. So this figure, they're going to go 4 units to the left and then 2 units down. So 1, 2, 3, 4, and then down 2. So it gets a little bit more tricky as they go. And there we show 2 movements, and you can see that the orientation has not changed. This one, the next 2, they have 2 movements each. Then we're going to move on to rotation. So in rotation, they're going to be rotating this figure around the origin, and I've given them a formula that they're going to use in order to do that. So they're going to take each one of these points and they're going to change it to another point using this formula, -yx. And this is the formula for moving clockwise 90 degrees. So if they go clockwise, or counterclockwise, counterclockwise 90 degrees, that would put this next figure in quadrant 3. So let's see what happens. This point is -1, 2. if we use this formula, we're going to get -2, -1 for our next point. Now we have -1, 4. If we use the formula, we have -4, -1. And then the final point, -3, 2, will now be -2, -3. And so they can finish their triangle. We've got these movable lines here to finish the sides of the triangle. They just click and hold, and then they can move these into place. Same with the points. We just click and hold. So there we show a movement counterclockwise 90 degrees. The next slide is going to show a movement clockwise 90 degrees using a different formula. And if we move clockwise 90 degrees, it will again be in quadrant 3. So they're going to do the same thing. They're going to take each point, using this formula, find a new point in quadrant 3. Here they're going to be moving 180 degrees using this formula. And then on the final rotation slide, they're going to be using 3 different rotations. They're going to show this triangle as it moves all the way around from quadrant 1, 3, and 4, using these points and these lines. And it gives the formula for each one of those movements. Then we're going to move on to dilation. Dilation is changing the size of a figure without changing its shape by a scale factor. So this one we have a scale factor of 2. That means it's going to be larger. It's going to be 2 times larger. So we're going to take each of these points and we're going to multiply the coordinates by 2. So here 1, 1 will now be 2, 2. -1, 1 will now be -2, 2. Let's see, right here, and then so on. So it's going to show a square shape that's twice as big once they've completed each of these. So you want to have them start with each of the points so they know where to place the lines. Then they have a triangle shape. So again, they're going to take the coordinates of the point. The scale factor is 3, so they're going to multiply the coordinates of each point by 3. Now they're shown what happens when they have a scale factor that's a fraction less than 1. So they're going to take each of the coordinates of these corners and they're going to multiply times 1/2, which is the same as just dividing by 2. And they'll get a smaller figure, same shape, but 2 times smaller. Then the final slide, students are going to be showing 2 transformations of the same figure. So here they're going to translate 5 units to the left, and then they're going to reflect that figure over the x-axis. The final slide has drag and drop vocabulary. So students are just going to click and hold on the edge of each of these terms, move them into the correct place. So this one would be rotation, and then they can place the other 3 in the correct place. It's a good review for what they've just learned. So this is Geometric Transformations, the Thanksgiving version.